Good afternoon, students. Today we will perform first experiment, generation of continuous and discrete elementary signal. Neil, am I audible? Hello? Hello? Generation of continuous and discrete elementary signal. Periodic and non-periodic signal using mathematical expression. Means we have to generate with the help of Scilab elementary signal, periodic elementary signal and non-periodic elementary signal. We will generate sinusoidal wave. To write this one, to write or plot or generate elementary signal, continuous or discrete elementary signal, first you open SciNote. SciNote is like a notepad, and here you write a program for sinusoidal wave. I have already write this program in a file, this periodic wave, and I open this wave. Neil और सनी,
यस मैम।
स्क्रीन तुम्हें क्लियर दिख रही है?
यस मैम।
Okay. I have already written this program and saved this program in a file periodic.sce. Clear? Perform this practical with me. Here CLF. CLF means clear the figure window. And in this there is no figure window. Then you define this independent variable t. T is equal to 0 colon 0.01 colon 3.14 means starting point is 0, last point is pi 3.14 and there is an increment of 0.01. So first you define the independent variable, then you define functions y is equal to sine 2 multiplied by pi multiplied by t, 2 pi t. So first you define independent variable t is equal to 0. This is the first, this is the starting point and this is the last point, and increment is of 0.01. Then you define function. Here we have to plot elementary signal. So here we define sinusoidal wave. Y is equal to sine 2 multiplied by 3.14 multiplied by t, 2 pi t. Then subplot. Subplot 4, 1, 1. This subplot is new command, and this subplot, by using this subplot command, there are 4 windows or 4 windows in one figure window. Clear? And this is the fourth row. There are 4 rows, 1 column, and position of this plot is in first place. Subplot means, meaning of subplot or syntax of subplot is 4 means there are 4 rows in one figure window, 1 column, this 4 rows, 1 column, and this one indicates the position of this plot. Means first position is is for this plot. Then after subplot command, you write plot t and y, x comma y, and here this t represents x-axis. So plot t comma y. This is the one method of plotting sinusoidal wave. Then for second method, f is equal to 0.2, then t is from 0 to 10 with the increment of 0.1, 0, semicolon, 0.1, semicolon, 10. Means t started from 0, last point is 10, and there is an increment of 0.1. Then x is equal to sine 2 percentage 2 multiplied by percentage pi percentage t, then multiplied by percentage f. Means for first in this x is equal to sine 2 pi tf, value of f is 0.2 and value of t is 0, starting point is 0, so starting point of x is in this case t is 0, percentage pi means 3.14, and then we get the value of x for t is equal to 0. Then for next point, 0.1, then for 0.1 value of t is substituted as 0.1, f is 0.2, and then we calculate the value, then Scilab calculate the value of x, and then then next command is subplot 4. There are 4 rows in the same window, 1 column, and plotting of this function is in second place. After subplot, write the plot command t comma x. Then next is m is equal to 0 colon 0.01 colon percentage pi. Percentage pi means pi is written in Scilab as percentage pi, and value of percentage pi is 3.14. Then subplot 4 rows, 1 column, and position of this plot sine m, position of this plot is in third place. So plot sine m means first value of m is 0, then 0.01, then 0.02, and then plot the value of sine m. Last method is fourth method, x is equal to x, sine x is written in this factorial form. Sine x is written as x minus sine dot caret 3 slash factorial of 3. Similarly, this expression is written, and then this sine x is plotted in fourth row, first column, and fourth position. Plot x. Clear? Then when you write this program in Scilab, then you go to execute, save and execute. And you get all the 4 sine waves. For this, you get this. There are 4 windows in one figure window, and this is plotted in first position, second is plotted in second position, third one is plotted in third position, and fourth one is plotted in fourth position. Clear? Sumit? Sumit, Sunny, आरू, क्लियर है?
Yes, ma'am.
Yes, ma'am.
Okay. Then minimize this. If you write 2d3 d3 second 2d3 2d3 and in previous file I changed only in previous file I write plot t and y. Here I write for discrete signal. For discrete signal we simply change plot 2d3 in only there is change in only plot command. Plot 2d3 plot 2d3 and plot 2d3 means plot 2d3 is used for discrete signal and plot is used for continuous signal. This is the discrete continuous elementary or sinusoidal wave. Clear? Next, non-periodic wave. This is the program for non-periodic elementary signal because this is the expression for sinusoidal wave, and here CLF, clear the figure window, then y is equal to rand RAND 1. Write this command in console and you get only one random number. Each time you get different random number by using this command. Then x is equal to from -5 colon 0.1 multiplied by y colon 5 and z is equal to sine, expression for sin x. Then x, what is the range of x? X from -5 to 5, increment of this, and then plot z. When you write the whole program, then go to the execute, save and execute. And you get a graphic plot like this. Clear? Then for discontinuous non-periodic sinusoidal wave of this open. There is no change in the program. Only here we write plot 2d3 CLF, then y is equal to r a and d ran of 1. From this command you get a random number, single random number. Write this y is equal to RA and D. 1, you get one single random number. If you write this command in console and then define x, and this is the expression for sin x, and plot 2D. Then after writing the complete program, go to execute button, save and execute. You get the discrete non-periodic waveform. One minute, please. This is our first program. Then next program, second experiment is generation of continuous and discrete unit step signal. For second program, write the object generation of continuous discrete unit step signal. This is a program for generation of unit step, continuous and discrete unit step signal. First you define t is equal to 0 semicolon 1, means starting point is 0, end point is 4, and there is an increment of 1. Then you define y is equal to once 1 comma 5. 1 means there is one row and 5 columns, one row and 5 columns of only one and of ones. So you get row vector 1 comma 1 comma 1 5 times 1. Then subplot 2 comma 1 comma 1. It means that there are two rows in one figure window. There are two windows in one figure window, one column, and position of this plot is in first position. Then plot 2D 3 ty x label. If you want to label the x-axis, then write x label round brackets time between this inverted commas, and similarly y label round brackets in inverted commas amplitude, write amplitude. Then title also in round brackets, and within inverted comma write down unit step discrete signal. Then subplot 2 comma 1 comma 2. 2 means there are two windows in one figure window, one column, and position of this plot is in second position. Then plot t comma y, x label time, y label amplitude, and title is unit step continuous signal. Then go to the execute button, save and execute, and you get the I'm not writing here, I'm not writing CLF, so this figure window is not clear, but this is the discrete unit step. Starting point is 0, last point is 4, and this is there is an increment of 1, 1, 1, and so this is the unit step discrete signal, and this is the unit step continuous signal. And this figure, because I am not writing here CLF, so last window is not in clear position. क्लियर हो गया तुम लोग को ये दो एक्सपेरिमेंट? नील,
Yes, ma'am.
कोई प्रॉब्लम?
No, ma'am.
स्क्रीन क्लियर है
Yes,
और
ma'am.
प्रोग्राम क्लियर?
Yes, ma'am.
ठीक है, तो ये तुम्हारे दो प्रोग्राम हैं और इन प्रोग्राम्स को जो है अपनी फाइल में लिख लेना. राइट डाउन दीज टू प्रोग्राम्स इन योर फाइल. Okay, class is over. I'm taking only attendance. Okay, thank you. Class is over.